Distribution substation costs and bus schemes. Hello everyone, my name is Rafael. I'm an electrical engineer, and in this video I would like to have a conversation with you about the distribution substation costs and bus schemes. Let's read this text and debate the concepts. Distribution substation design has been somewhat standardized by the electric utility industry based on past experiences. However, the process of standardization is a continuous one. Figures 4.6 and 4.7 show typical distribution substations. Let's see the figures. Figure 4.6, a typical distribution substation. Figure 4.7, a typical small distribution substation. Let's return to the text. The attractive appearance of the substations is enhanced by the use of underground cable in and out of the station, as well as between the transformer secondary and the low voltage bus structure. Automatic switching is used for sectionalizing in some of the stations and for preferred emergency automatic transfer in others. Figure 4.8 shows an overall view of a modern substation. Let's see figure 4.8. Overview of a modern substation. Returning to the text. This figure shows two 115 kV 1200 amperes vertical brake-style circuit switchers to switch and protect two transformers supplying power to a large tire manufacturing plant. The transformer located in the foreground is rated 15, 20, 28 MVA. 115, 4.16 kV, 8.8% impedance. And the second transformer is rated 15, 20, 28 MVA, 115, 13.8 kV, 9.1% impedance. Figure 4.9 shows a close view of a typical modern distribution substation transformer. This is figure 4.9. Close view of a typical modern distribution substation transformer. You can see this is a three-phase transformer and not a set of monophase transformer, single-phase transformer connected in three-phase. Returning to the text, a typical substation may include the following equipments. Very, very important this. Let me highlight this. Very important. Number 1, power transformers. Number 2, circuit breakers. Number 3, disconnecting switches. Number 4, station buses and insulators. Current limiting reactors, shunt reactors, current transformer, potential transformers, capacitor voltage transformers, coupling capacitors, series capacitors, shunt capacitors, grounding system, lightning arresters and or gaps, line traps, protective relays, station batteries, and other apparatus. From these, circuit breakers, very important for distribution engineers, circuit breakers, current transformers, and potential transformers, and here protective relay, they make up the protection equipment of the substation and or the lines. Then these equipments here, circuit breaker, current transformers, potential transformers, and protective relays are very important for protection. Let's continue. Now we are going to speak about substation costs. Substation costs include all the equipment and labor required to build a substation, including the cost of land and easements, rights of way. For planning purposes, substation costs can be categorized into 4 groups. Site costs, the cost of buying the site and preparing it for a substation. Transmission cost, the cost of terminating transmission at the site. Transformer cost, the transformer and all metering, control, oil spin containment, fire prevention, cooling, noise abatement, and other transformer-related equipment, along with typical bus work, switches, metering, relaying, and breakers associated with this type of transformer and their installations. Feeder, bus work, getaway costs, the cost of beginning distribution at the substation, which includes getting feeders out of the substation. The site depends on local land prices, real estate market. It includes the cost of preparing the site in terms of grading, grounding mat, foundations, bare duct work, control building, lighting, fence, landscaping, and access road. Often, estimated costs of feeder bus work and getaways are folded into the transformer cost. Substation costs vary greatly depending on type, capacity, local land prices, and other variable circumstances. According to ABB Guidebook, substation costs can vary from $1.8 million to $5.5 million based on 94 prices. It depends on land costs, labor costs, the utility equipment and installation standards, and other circumstances. Typical total substation cost could vary from between about $36 per kilowatt and $110 per kilowatt, depending on circumstances. Now, let us see example 4.1, which is going to talk about the costs. Consider a typical substation which might be fed by two incoming 138 kV lines feeding two 32 MVA 138 kV 12.47 kV transformers, each with a low voltage bus. Each bus has 4 outgoing distribution feeders of 9 MVA peak capacity each. The total site cost of the substation is $600,000. The total transmission cost, including high-side bus circuit breakers, is estimated to be $900,000. The total costs of the two transformers and associated equipment is $1,100,000. $1,100,000. The feeder bus work getaway cost is $400,000. Determine the following. Letter A. The total cost of this substation. Letter B. The utilization factor of the substation if it is going to be used to serve a peak load of about 50 MVA. The total substation cost per kVA based on the aforementioned utilization rate. Now let's see the solution. The total cost of the substation is $600,000 plus $900,000 plus $1,100,000 plus $400,000, and it is going to be equal to $3 million. The utilization factor of the substation is FU is equal to the maximum demand divided by the rated system capacity, 50 MVA, divided by 2 times 32 MVA, which is approximately equal to 0.78 or 78%. The total substation cost per kVA is $3 million divided by 50,000 kVA, which is $60 per kVA. Okay, people, now let's finish with substation bus schemes. A very important topic for distribution engineers. The electrical and physical arrangements of the switching and busing at the sub-transmission voltage level are determined by the selected substation scheme or diagram. On the other hand, the selection of a particular substation scheme is based on safety, reliability, economy, simplicity, and other considerations. The most common use of the substation bus schemes include, let's highlight this because it is important, single bus scheme. Number one, single bus scheme. Number two, double bus double breaker or double main scheme. Number three, main and transfer bus scheme. Number four, double bus single breaker scheme. Ring bus scheme. Breaker and a half scheme. Now let's see. The book is gonna give us some schemes to see. Let's begin with figure 4.10. Figure 4.10 shows a typical single bus scheme. So this is figure 4.10, a typical single bus scheme. Can you see? The incoming line, the circuit breaker, the bus, and other breakers with disconnecting switches. Figure 4.11 gives a typical double bus, double breaker scheme. So this is double bus, double breaker. You have one bus here and the other bus here, and between them, two breakers. Figure 4.12 illustrates a typical main and transfer bus scheme. Let's see. Here you have the main bus, and here you have the transfer bus. When there is need of maintenance or repair along the main bus and attached equipment, you transfer the load to the transfer bus while you conduct maintenance on the main bus. When everything is done and ready, you disconnect the transfer bus and use the main bus again. Figure 4.13 shows a typical double bus single breaker scheme. Let's see. Double bus, a typical double bus single breaker scheme. You see two buses here and one tie breaker between them, and here you have other breakers with disconnecting switches here. The incoming line will be here, this way, and the outgoing line will be this way here. For 4.14 gives a typical ring bus scheme. Let's see the ring configuration. You can see here the ring, okay? You have multiple circuit breakers here with switches. You can perform maintenance and repair using these disconnecting switches. You are going to disconnect the part that you want to conduct maintenance, or maybe if you don't want to let every one of them close, you can simply open them, and the circuit breaker only operates during faults.